Chapter 7 is about exponents and power functions. So today we're going to look at the graphs of different power functions and analyze their properties. So just some basic terminology to start. If we have x to the n, x is considered the base, and n is considered the exponent, and the whole expression x to the n is considered the power. So if I want to take a look at different power functions, then we're going to look at different values in the exponent. So the first one we're going to look at is power of 1, which is y equals x to the first, which we know is linear. And the second one we're also very familiar with is an exponent of 2, which would be y equals x squared, which is quadratic. So pause the video for a second and then fill in these two tables and then take a look at those graphs. You should be very familiar with linear looking something like this, going through 0, 0 with a slope of 1, and quadratic going through 0, 0 with an ordered pair of 1, 1, 2, 4, and 3, 9. So those should look familiar. Let's go ahead now and look at y equals x to the third, which we're going to say is cubic. So let's go ahead and fill out this table again. Pause, and then come back and take a look at that graph. So this graph should look something like this. So you should have the ordered pairs -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. So you get kind of this S-shaped curve through here. So that would be what all cubic functions look like. Moving on to the power of 4, y equals x to the fourth, and y equals x to the fifth. X to the fourth is called quartic. I kind of remembered as 4 quarters in a dollar, and fifth for fifth power. Anything beyond that is just the value, so 6th power, 7th power, etc. 1 through 4 are the only power functions with special names. So go ahead, fill out these tables, and take a look at the graphs. Hit pause, and then come back. So x to the fourth, your table should say -2, 16, -1, 1, 0, 0, 1, 1, and 2, +16. And that graph should look like a parabola, just a little bit steeper. And x to the fifth should have -2, -32, -1, -1, 0, 0, 1, 1, and 2, 32. So again, it's going to have that S-shaped curve as x to the third did, but steeper. So if you kind of think about the pattern you're seeing, after x to the first, every even power is going to look like a parabola, or an x to the fourth, or an x squared, and then every odd power is going to be the S-shaped curve that we were just looking at. So we are going to be able to talk about, in general, what properties of even and odd functions. All of the power functions go through 0, 0, as you'll notice. The domain of an even power, so those are your parabolas, would be x equals all reals. That should be review. And then the range would be y is greater than or equal to 0. Again, review. Greater than or equal to 0 will always be true, again, because your power functions go through 0, 0. Symmetry should also be familiar. That will be reflection symmetry over the line x equals 0, or the y-axis. Odd powers, those are your S-shaped curves. That domain would also be all reals. That range is going to be y equals all reals. And this symmetry is actually rotational symmetric around 0, 0. So you would say it would be rotated 180 degrees around 0, 0, and that would be your symmetry for those S-shaped curves. So if we look at some of the properties that might be asked in relation to this section, just kind of also remembering how to evaluate in orders of operations. So 2 to the fourth is 16. The quantity -2 to the fourth is also 16, but this third one says the opposite of 2 to the fourth, which would then be -16. Because if you are doing your orders of operations, you should do your exponents first and then apply the negative at the end. So that would be -16. So just be really careful and pay attention to when parentheses are being used and when they're not being used. An application question. Suppose there are 10 questions on an advanced algebra test and each questions have 4 options. What is the probability of getting all 10 questions correct? Well, if I think about the probability of just getting one question right, if I have 4 options, my probability would be 1 out of 4. And there's 10 questions, so I could say 1 out of 4 times 1 out of 4, etc. for all 10 questions. Or shorthand, I could just write 1 out of 4 to the 10th. You could go ahead and type that into your calculator, but I'm more interested in looking at the expression rather than the very small decimal that you're going to get. So we can just leave that as an expression. Letter C, looking at those graphs again, so it's going to say the point -2, -32 is on the graph of an odd power function. What other point must be on the graph? Well, if I think about this, -2, -32 is someone way down here. And if I know it's an odd power, then that's going to be one of my S-shaped curves. So it'll look something, oops, like this. So if I think about the reflection of -2, -32 from down here, and I reflect that, that point's going to be up here. And then that point would be at 2, comma 32. So +2, +32. The equation then, so every power function is going to have the equation y equals x to the n. So I just need to know what value of n is going to make that true. So if I'm thinking about 2 and 32, I'm really saying 2 to what power is 32? So that would be 5. So 2 to the 5th gives me 32. So y equals x to the 5th is the function I'm looking for. Letter D, if n is even, then the range of x to the n is blank and the graph is in quadrants blank and blank. So even is a parabola. So the range of all parabolas is y is greater than or equal to 0. And the parabola would have been through here. So that would have been in quadrants 1 and 2. Example E, if n is odd, the domain is all reals. That's your S-shaped curve. And then the quadrants that we were just looking at for this one then will be 1 and 3. Question F, which one has reflection symmetry? So reflection symmetry was an even function. So if I'm looking at an even function, I am looking at the exponent, and that would be y equals 3x to the 8th. And last but not least, question G, the point -216 is on the graph of an even power. Write the equation. So again, our equation is going to be y equals x to the n, where n is my exponent. So I know it has to be even, so that could be the second power, the fourth power, the sixth power, etc. But I know -216 is on that point. So 2 to what power 16? 4. So y equals x to the 4th is the equation I'm looking for. So that is the basics of power functions.